Hello, I'm going to go over how to run a Dino model in R using the CDM package. I'll be using the dataset Beck's depression inventory. Now, Dino stands for Deterministic Input Noisy or Gate Model. It's a type of CDM. In this example, the CDM will help us to basically generate this sort of profile on each participant based on the specific symptoms that would make up depression. So if you have something like a latent continuous variable like depression that can be broken down into some categorical variables or a handful of them, you can begin to profile a participant on the symptoms that would make up this variable that you're trying to measure, like depression. Now, first thing is to get the data set. It's located in a package called KernSmooth IRT. I've installed it already. Next step is to actually remove the NAs. This is something only I'm doing. I just want a clean data set. The main goal is just to go over how to run a Dino model in R and nothing else. There are much better ways of handling missing data. Now, the next step for me is I want to sort of create a Q matrix, meaning I want to link each item, or I want to link symptoms to each item. So, but I don't really have, now this is also not the best way of doing this. What I'm going to do is a factor analysis. Past research has shown that there are three latent factors in this sort of Beck's depression inventory. It's called the negative attitudes, performance difficulty, and somatic factor. This is like a very rough way of trying to get a sense of where these items are, and basically all I'm going to be doing, this is just a quick and dirty way of doing it, is I'm going to be using the factor loadings. Past research shown that there are three factors, but I'm just going to be looking at the positive factor loadings for each item. Now, there are 21 items, and I expect there to be these three latent factors, and I'm going to use this to generate my Q matrix. So, for example, item 1 here, I can see there's a loading on factor 1, and that's pretty much going to be the first entry into the Q matrix. Now, the Beck's depression inventory, the data ordinal is from 0 to 3. For the Dino model, it's a binary model, and what I want to do is to quickly make it turn the responses binary. So anything greater, what this function is doing is any value greater than 0, I'm going to flag it as a 1. Basically also meaning what I'm basically doing is an examinee selecting a value 1 or higher is endorsing that item. And this is the Q matrix that I developed based on the factor loadings manually. Now, as you can see here, this would be item 21. There were three factors associated with it right here that I'm linking. In this Q matrix, I'm linking all three attributes to item 21. So I'm just going to run it, and I'm going to name it, turn into a data frame right here. And then I'm just going to name the column names symptom 1, symptom 2, and symptom 3. Now let's call the CDM package so I could run the Dino model. So here is I'm identifying the actual data set, the Q matrix that I generated, and I'm going to set the rule to Dino. Now, why use the Dino model? It's because of the assumption that it has. For for symptoms here, it's possible for participants to have more, can have more than one symptom and can show different symptoms and still select or endorse the items. For example, let's a specific example would be, let's say right over here, this is item 4. All three symptoms are linked to this item. However, for the Dino model, if an examinee or participant is really high in one of the symptoms, that would sort of compensate for not necessarily having the other two symptoms. This is a little different than the Dino model, which would require that the participant would have to have all three in order to endorse this item. Now, why use this model that has this assumption? The reason's because I expect there to be differences in symptoms, yet, like, for example, if one of the symptoms is negative attitudes and another symptom is poor performance or a performance difficulty, then you can still have just show this one symptom, yet still have depression in this way and still answer multiple items or endorse multiple items to indicative of depression. So I'm not constraining, and I do want to have this sort of flexibility. And you can compare models if you want as well. But that's the reason why I'm selecting Dino model here. Now there are a few things that I'm overlooking. It's ordinal data. I'm turning it binary, so that may not be the best approach. I also didn't use the best approach for developing the Q matrix, but again, this is only just to run the Dino model or demonstrate it using R. So after I've loaded the CDM package, I'm going to run it. The model converges, and now let's try and review the output. So here are the relative fit statistics that you can compare. So now here is what I'm most interested in, because I did just throw together this Q matrix. The guess and slip parameter are under item parameters. First, you can look at the guess and slip parameter, the root mean square error. This right over here, the values you want most are 0.05. That would indicate it's good. Anything less than 0.1 is moderate, and you can see here the fit is pretty good for each item. It's how and actually I don't see anything higher or anything indicating it's a poor item fit for any one of these. Now the IDI is the discrimination, and here what I want the most is values close to 1. Any values close to 0 is what I don't want, and negative values means pretty much a violation in the assumption that the probability of not slipping is somehow lower than guessing. And as you can see here, a lot of them are closer to 0, not as close to 1 as I'd like, so indicating it's poor discrimination. So and that could be indicative of the Q matrix specification. So it's not necessarily ideal, but again, this was just to demonstrate. Now the marginal skill probabilities are the proportion of examinees for possessing each symptom. Like how many like 33% of examinees have symptom 1 right here. Now the correlations, you can look at the correlations between the symptoms right here. Nothing extraordinarily high, like 0.9. And also the It's called scaled pattern probabilities because most often time these models are used for skills. But in this case, the attribute is possessing symptoms. Now, from this, you can see the first one being 000, 47, 48% have none of the symptoms here, indicating that a lot of the participants did not did not really possess a lot of the depression. So it may have been given to a a, a sample that may have not had a lot of the symptoms of depression. Now, what I want to do is actually classify or develop, or I should say, profile on each participant on whether they have the symptoms. This is like the main thing that I would want to do. And right here, I'm going to use maximum likelihood estimation. I'm just going to look at the first 10. Adding this will just make you look at the first 10. And what it'll indicate is whether each row represents an examinee has the actual symptom. And this is what it'll do. It'll give you this breakdown for each one. So you can say examinee 1, he or she only has the second symptom, which can be anything. Now, and pretty much that's pretty much it. Just running the Dino model using R. Again, this isn't necessarily the best way to develop the Q measure. There are other ways to do it, more appropriate. But the goal was to just go over how to run a Dino model in R. So please let me know what you think, or if you have any questions. Thank you.